Okay, now in this you're going to learn something new. There's one of the lines I keep crossing out. Well, that stops right now. Okay, the square root of x, square root of 2, you need to simplify that. And some of you are like, well, it looks pretty simplified to me. Well, no, it's not. Here's what you're going to do. You're going to put square root of x, square root of 2. You're going to make one little expression to the half power and put x over 2. So that's nothing new. You can't divide much of anything. So, and you're going to do something in this line I've been crossing out. So you got x, 2. Okay. So they both be to the 1, but they both are multiplied by a half. So it's 1/2, 1/2. Okay. No negatives. That won't be an issue. That'll be crossed out today. Now you don't have any full exponents. They're just rationals. So you bring over your x to the 1/2 and your 2 to the 1/2. Do a root check. In the square root list, I don't think x comes up, neither does 2. Just because it comes up over here, that doesn't mean anything. Now, you have a fraction exponent in the denominator, a rational exponent. Well, you can't have a radical in the denominator, and that's what you're going to end up with if you just keep that the way it is. So if you see a fraction power in the denominator, you need to carry out this step. It's called rationalizing the denominator. Rationalize. Well, here's what you do. Drop everything down. And this fraction here, you need to times by another base of 2. You need a 2 in the denominator of your exponent, and whatever you put on top is whatever 2 minus 1 is. Okay? 2 minus 1 is 1, so it's 1/2. Now, since we're timesing the bottom by a half, you got to times the bottom by that same factor, 2 to the half power. Now, here's what's going to happen. The bottom's set, okay? Now, here's what we do on bottom. We combine these, okay? You got 2, and then you add 1/2 and 1/2. 1/2 plus 1/2. 1/2 plus 1/2 is 1, okay? So it's 2 to the first power. And now we have a full exponent on bottom, okay? 2 to the first. So again, you times by the same base with the same bottom, and then the top is whatever the bottom minus the top is, 2 to the first, okay? Now everything's the same. You bring over your 2 to the first. You make these into a radical with a 2, okay? And you're going to put x to the first, which is x, and then 2 to the first, which is 2, okay? So 2 to the first is 2 on the bottom. You're going to have your radical 2 with your x. Now the square root of 2, it doesn't divide by any of this stuff, so we just keep the 2 in the radical in front of the x, so that's simplified. You can't end up with a radical in the denominator, and you will if you don't get rid of that fraction power. Okay, next one. It's a little bit tough when you get used to it, okay? So you got the square root of 5 and the square root of 8x. So you make it all to the half power, and then you just put a 5 and an 8x, okay? Okay, so you have a base 5, and on bottom a base 8 times a base x, okay? So 1 times 1/2 is 1/2. 1 times 1/2 is 1/2, and 1 times 1/2 is 1/2. So you don't have any full exponents, just bring over your rational exponents. Circle them as you bring them over, just like you've always done. Okay, do any of these turn up here? So square root 5, nope, not there. 8's not here, and x certainly isn't going to be there. So unfortunately, I can't simplify any of them right now. Okay, so the top's fine, but you need to rationalize on the bottom because you have fraction exponents on the bottom. Okay, I'm fine with whole exponents on the bottom, just not the ones with fractions. The one on the top doesn't matter. Okay. Now start with your 8. Does it have a fraction exponent? It does. So what you do is you write everything on top first. Now go to your bottom. 8 to the 1/2 power. Okay. So that's a fraction. That's not cool. So we times 8. Put a 2. 2 minus 1 is 1. Okay. Now you also got to times that to the top as well, whatever the new factor is. Now you've also got x with the fraction too. So x to the 1/2 power. Okay. Times x. A 2s go on bottom. 2 minus 1 is 1. Okay. And you can't forget to times it on the top. Okay. Now here's why I do that. Because we have two base 8s. A half plus a half is 1. So this is now 8 to the 1st. Okay. A half plus a half is 1. So this is now x to the 1st. Now I don't have any rational exponents on the denominator. Okay. Now 8 to the 1st and x to the 1st are just brought over. But all of these have 2's in the denominator, so you make a square root. You got 5 to the 1st, which is 5. 8 to the 1st is 8. X to the 1st is x. You need to times the 5 and the 8. That's 40. Now you got 8 to the 1st is 8. X to the 1st is x. Then you make your radical. You put the x, but you have to break down possibly the square root of 40. Okay. Now you're on the square root list. So 40. 40 divided by 36, no. Divided by 25, no. 16, no. 9, no. 4, yes. If you divide 40 by 4, the result is 10. Okay, so a 10 stays inside, 2's outside. I'm fine with that as the answer. You could reduce the 2 and the 8, not the 10 though. The 2 and the 8, you could make that a 1 over 4. But the 10 stays put. Okay, keep watching. Got 6 more. The cubed root of x divided by the cubed root of 2. So x, 2. Can't do much to divide. X over 2, 1, 1. 1 times 1/3 is 1/3. 1 times 1/3, 1/3. Okay. No negatives. Okay. You don't have any full exponents, so you bring over the rationals. Circle the bottoms as you do it. You do a cubed root check, and x and 2 are not here. Okay? So you can't get rid of them now. Do you have a rational exponent on bottom? Yes, you do. That can't happen. So you need to use this space. You just write down everything on top first. Okay? Now look at your first base. That's your only base. 2 to the 1/3 power. Well, that has a fraction exponent. That doesn't work. So times 2, put a 3. What's 3 minus 1? It's 2. Okay? See, and you got to times the top by the same thing. See, if I combine these 2's, the bases, I'd add the exponents, and 1/3 plus 2/3 is 3/3, which is 1 whole. Okay? So that now becomes 2 to the 1st. Why? Because you're adding 1/3 and 2/3, and it's 1. So we combine it into 2 to the 1st. You can't forget to bring that up. That new factor you brought in's got to go on top too. So you got 2 to the 1st. Now, you need to make a cubed root. And in that cubed root, you're going to put x to the 1st, or x, and then 2 to the 2nd. Now 2 to the 2nd's 4, okay? 2 times itself, so replace that with 4. So 2 to the 1st is 2, then you bring your cubed root, you're going to have x inside. Now how about the cubed root of 4? Can you really simplify that into... I don't think 4 divides by anything, it's too small, so that 4 stays put. You cannot reduce that one, the 4 and the 4, when one's inside and one's not in a radical, you can't do that. Okay, next one, I got the cubed root of 5 divided by the cubed root of 3x. Cubed root of 5 divided by the cubed root of 3x. Okay, so you make it into 1/3. 5 divided by 3 is a decimal and it can't be reduced, so we'll leave that as 5/3. And then x on bottom. So we got a base 5, a base 3, and a base x. All these are to the 1, but they all get multiplied by 1/3. So 1/3. Okay, you don't have any whole exponents. You got all rationals, so you got 5 to the 1/3, circle the bottom. 3 to the 1/3, circle the bottom. X to the 1/3, circle the bottom. Look at your 3 list, cubed roots. You're not going to see 5, you're not going to see 3, you're not going to see x. So I'm out of luck there. Okay, now you have those. Whenever you got those fractions in the denominator, you need to use this step to rationalize. So when you rationalize, you just copy whatever's on top. Now the bottom, that has a fraction. So you need to times by a 3, put a 3 as your base, and then 3 minus 1 is 2. So you got to times the top by 3 to the 2/3 power. Now you're not done. You've also got the x, okay? X to the 1/3 power. Well, that I do the same thing. Put a 3, but 3 minus 1 is 2, so your x has to be to the 2/3 power up here. Now the point of that, now that's 3 to the 1st, and that's x to the 1st. So now the fractions are out of the bottom. So on bottom you got your 3 to the 1st times your x to the 1st, and then the bottoms are all cubed roots. So we make a big cubed root, and put 5 to the 1st, which is 5. 3 to the 2nd needs to stay 3 to the 2nd, and x to the 2nd. 3 to the 2nd's 9, okay? And then 9 times 5 is 45, so you evaluate the 3 to the 2nd, 9 times 5 is 45. So it's 45 times x to the 2nd. That's a 45 times x to the 2nd. Because you had 5 to the 1st times 3 to the 2nd, which is 5 times 9, which is 45, then the x to the 2nd. Okay, 3 to the 1st is 3. X to the 1st is x, and we know we have x to the 2nd inside, but the 45 right there, we need to see you talk about simplifying that. So 45, we'd start dividing it at 27, nope. You remember, you'd be on the right list. Then 8, nope. So if nothing works, we keep 45 inside. Okay, next up, the 4th root of 2 divided by the 4th root of 5, so you make it into one whole quantity to the 1/4 power, and then 2 doesn't divide by 5, and 2/5 can't be reduced. So you got 2 and 5. 1 times 1/4 is 1/4, and the same thing on bottom. Okay, bring those over. There's no whole ones to bring over. Do a root check with 4th roots, and 2 and 5 are nowhere to be found, so you can't do anything about that. Okay. Well, that little circle on bottom that I made, that's not going to work. You can't have a fraction exponent on bottom. You have to rationalize. So you take your top, 2 to the 1/4, you just copy that down. Now your bottom, that has a fraction, so you times 5, make a 4. What's 4 minus 1? 3. Then you times the top by 5 to the power of 3/4. Okay. Now the reason we do that, because now I can make it into 1/5, and that makes one whole. 1/4 plus 3/4 is one whole. But you got to remember, you also got to do it on top. Okay, so the whole exponent I have is 5 to the 1st. Now the fraction exponents we got, both a fourth, so 4 through it, and then I got 2 to the first, which is 2. 5 to the third is 120, 120, and then 5 to the third. I don't want to skip steps. 5 to the third. 5 to the third is 125, and then 2 times 125 is 250. So you need to simplify that inside. So 5 to the first is 5, and then I make my fourth root. Now I want to see if I can simplify the fourth root of 250. Now remember to look at the right list. If it's a fourth root, you're going off of these. 81, nope. Nope. So guess what? It stays 250. And you can't reduce that when you have one in a radical, one not. Okay, next one. We have the square root of 3xy to the second divided by the square root of 5xy to the third. Okay, so it's all square roots, so we put 1/2 power for a square root. 3 divided by 5, no. So it stays 3 over 5. x1. Well, hold on a second. My battery's about to die. I gotta switch batteries.